let's have next speaker. Do you think you can launch the presentation yourself? So Gal Offel is Head of Software Solution, PLM, at Telco System. He's the Head of Software Solution Product Line Management, which is just what I said, so for those who follow. So he's responsible for the software products and the related ecosystem, including Telco Systems' Open Metro Edge solution for SDN and distributed NFV for service providers. And Gal has 15 years of experience in the high-tech industry, mainly in senior product management and pre-sales positions, including Perfecto Mobile, Converse, Shunra, and Demantra, Oracle, and Zoostr.
Thank you, Jean-Marc. It's the last session for today, so I promise not to keep you too long. Actually, it's very exciting to be here because we all share the same goal. We all want to make NFV a reality. And some of you spoke about the different challenges, organizational challenges, technology challenges. I'd like to share some of the lessons that we've learned in the last year. We are all running proof of concepts of NFV. And we've learned that security is something that is a big challenge. How to protect NFV, we believe that there are some unique aspects to the NFV infrastructure that need to be taken care. I'll also share our thoughts or what we are implementing as a product for that aspect. One moment, I have a problem here. Is it possible to make it slide mode?
Are you in presenting mode?
Not sure. No, that's okay.
Are you sure? Sure it works.
Okay. So yeah,
when you click?
Yeah, it works.
Okay, so
yeah.
follow here.
Okay, fine. So the first part of the presentation is a bit conceptual, looking at the different challenges. So in NFV, many things changes. Our network is changing. Our devices. The way that we configure the network, and we'll go one by one of each one of these items. So the first part is we are moving from a hardware-based environment or hardware-based forwarding into software data plane, and from an environment where we had dedicated hardware components like ASICs, FPGA, bypass mechanism, we are moving parts or all of the parts of the forwarding into software. Now, this brings a vulnerability that we didn't experience before, where our virtual functions or network functions are now much more vulnerable to denial of service types of attacks. So let's say that we have a hardware-based switch or router that supports 40 gig maximum capacity. Now, we're migrating that into software. It could be also a firewall, for example. Now, with the hardware-based switch, it would be, we overloaded, and usually it would be quite hard to break it. Okay, it knows how to drop packets and maintain it. With software-based forwarding, the challenge is much higher. It's easier to either crash the virtual functions once we load it, and also it's not only that specific function, that VNF, but it could actually make the whole host unresponsive or make the whole host fail. Okay, second aspect is the open source environment that we are operating in. There are lots of open source tools that are used, such as hypervisor, virtual switching, compute node management, and others. If you take, for example, OpenStack, there are over 1,000 developers working on it. Think about the amount of codes of line that could be compromised, as happened with hypervisor last year. Okay, so we have a huge challenge that we have a component that we have some unknowns regarding it. Looking at the overall environment, when we're taking a specific network function and we're virtualizing it, so we're taking a physical device, creating a VNF. This VNF may be executed over multiple virtual machines, and these would be hosted on a server or on a universal CPE, as we saw before. And these devices would be distributed around the network. Now, if we do a zoom in into the NFV host, and we can have thousands of these on our network, we can see that each VM is actually a whole operating system with software. Now, this means, and usually that would be, it could be different types of operating system depending on the VNF developer, VNF vendor. Now, this provides or enables to host different types of attacks. Okay, it could have an ability to get some malicious codes, some backdoor codes, and different ways to attack it. On the other hand, while looking at the NFV infrastructure on a specific host, we have the control plane and management planes that are quite comprehensive. So we have the control and management of the compute node. We might have for the virtual network, for the hypervisor, and each one of the virtual machines, each one of the VNFs might have its own management interface. Now, this creates another level of vulnerability where there are different interfaces that malicious activity could be utilizing or trying to attack. And we also have the complexity that we might have some malicious code that will be residing on one VM, and that would be trying to access the host and actually break it. Okay, so and one other aspect is that everything now is dynamic. Relating to the previous slide about the control and management planes, some of the operations might be actually driven by end customers' activity. We have a residential customer or a business customer going into the service provider's portal, ordering online a service, and that will automate an entire process on the background. Now, in the old environment, things wouldn't happen in real time, and if something would change on our network, we might get some alarms or be notified. Over here, we need the mechanism to be able to identify whether this is a malicious activity or that it's something that is actually driven by a real customer doing a process in real time. We also have the inter-operator LSO activities that are also automated and might also, in the future, also launch different kinds of VNFs. Okay, so now I'll be looking into the types of existing threats that could be relevant for NFV or could be harmful for NFV infrastructure. So we spoke about doing the forwarding plane in software where we have high vulnerability to denial of service and different types of flooding attacks on all of the different planes of our NFV host. We have the ability to utilize the mainly the management but also the control planes to obtain control over a VM, over a host, and over the entire machine. It could be done by exploitation of the code, different types of attack, uploads of backdoors to the systems. One issue is that, for example, we could have a virtual function that would be a firewall, and that firewall requires to have ongoing updates to it. That's another threat that could allow to insert some malicious code into the system. Another aspect is that on a virtual environment, we don't have any more physical partitioning as we used to have in the past. In the past we would have a firewall, and that firewall will have different interfaces, physical interfaces that would be separated logically and physically. Now the NFV host is actually running a virtual network where that physical separation doesn't exist. There are some interesting use cases that were defined and tackled by the NFV security group that, for example, we are restarting a specific host. Now, what do we need to start first? Do we need to start first the network? Do we need to start the virtual network? Do we need to start first the virtual firewall that would be protecting us? Or do we need to do other things? So all of this complexity needs to be tackled. And another item is, and that's in virtual environment, that's a threat that is by order of magnitude much higher than in non-virtual environments. And that's a situation where, we all know that probably our networks are already compromised. We might have a PC that has some malware running on. It could be a server, or it could be even a smartphone that resides on the network. Now, in virtual environments, once we have a situation where we have malware residing on a specific virtual machine, that could be easily spreaded across our network. So that piece of code could duplicate itself to other VMs on the same host. It all happens on the same host, so it doesn't pass through the actual network. And it also could pass to other hosts and easily spread through the entire network. There could be two examples. One, once all servers, all hosts are infected, then somebody will push a button and will stop them from working, or they will spread until they reach a destination where that will allow remote access for hacking or other purpose. Okay, and of course the size of the threat is really large. We could have thousands or tens of thousands of hosts from CPE devices through cell site virtualization up to our core. Okay, so some examples from the last year about attacks. One attack was actually utilizing the hypervisor, some kind of hypervisor hole, where the floppy disk driver that nobody uses actually was used to escape from the confines of a VM and take control over the host and then over the network. It's relevant for KVM and also for XN. And actually, some of the cloud vendors needed to install a patch on all of their thousands of servers and then restart them. I'll skip fast also to some other examples. There's a very nice analysis by BT about the different vulnerabilities of OpenStack and the size of them. Okay, so looking at what should be a solution for protecting NFV infrastructure, in general, it's made of some components. The first part is the ability is to have an agent that constantly monitors our NFV infrastructure, and it's critical that it's done at the infrastructure level, basically monitoring constantly the hypervisor as well as the virtual network. It should run seamlessly without affecting the performance of the host. Secondly, we'd like to have local policy enforcement to be actionable on the host. So if we identify a threat, to be able to block, as a firewall does, but to block the virtual network. If it's a denial of service attack, we'd like to either offload the traffic to hardware or to offload to some DDoS protection on the cloud. In terms of DDoS, we'd like to be able to quickly identify an emerging attack. It would be hard to mitigate that attack on the device, so we need to identify that fast and send it somewhere else. And also be able to tackle APTs, advanced persistent threats, using advanced analytics, analyzing constantly the behavioral of a specific host and the entire network, and specifically be able to handle NFV-related attacks. Okay, in terms of the process of our NFVI protection solution, we have the first part, which is the collection. We mentioned the NFVI agent. In addition to that, we have a probe that could run either as a VNF or bare metal and could reside in different places around the network, and also collect log files of firewalls or any other piece of equipment that could be utilized. Then we have the aggregation part, which takes all of this information and builds different data structures, correlation, trends, and graphs that are used to run the different algorithms. The detection phase, either local for threats that could be analyzed on the host or overall on the entire system. And actions, as we mentioned, block traffic on a host, but also be able to automate our control and management solutions. For example, bypass a specific device, shut down a device, shut down a VNF, and so forth, and do that either in real time or to provide recommendations for the Security Operations Center. Okay, some examples of the visualization of such a solution after an alarm was sent to the SOC, visualizing threats or attacks geographically by port or protocol. This is actually very interesting to analyze attacks on control and management. Analyzing by host, the load on a host. It could be also interesting if we have a malware propagation from one VM to many others, then we could see some suspicious activity there on that, or one VM trying to contact another VM, which doesn't make sense. And creating graphs of our network, both of the flows and also who is accessing who. To summarize, NFVI protection solution must be a lower level solution. Running a VNF for protection won't solve the problem because it will not be able to monitor the hypervisor, the entire virtual network. We need to do it on the data plane so we can block and offload. Easily integrate that into various NFVI, and have the knowledge for creating the different algorithms analyzing NFV specific attacks. Thank you very much. I'll be happy to answer any question.
Thank you very much, Carl. Thank you. And thank you very much to bring up in this conversation the security aspect, which is definitely a super important topic as soon as we talk about IT services in the data plane of the network services. So that brings a lot of new challenges. Is there any quick question? Yes.
Hi, my name is Shine. I was wondering, we had a couple of guys yesterday and today talking about open source. What was your perspective in terms of using open source in this kind of environment? Would that accelerate actually the attacks, or would that have no impact?
Okay, so open source is a reality. We are using open source. We believe that a lot of the presentations that were today about VCPE are based on open source. We have to take this as a given thing. Like the example of the hypervisor, there are threats of the open source. We believe that a NFV protection solutions must be able to identify malicious activity that could come from such open source. So we should know if a router is trying to run a backup process on the firewall, then something is wrong. Okay, so the approach would be twofold. First, to have the mechanism to be able to quickly identify such a threat, and then need to go back manually to the open source code and fix that or install a patch.
Okay. Thank you very much, Carl. Thank you. Okay, so don't move away too much because there is no break before the debate. We just need a couple of minutes to install the stage here. Thank you very much. We start in a few minutes, and I promise you a very interesting conversation with the key service provider in a few minutes. Thank you.